This is the final project for Benjamin Meads and Val Clark. Our project is called PacerBot. It is a robot that is meant to follow the white line of a track and go at a specific speed. So while you're training for running, you know what pace you're running at. Our project uses two control loops, one for speed and then one for the steering using color sensors. We use two Arduinos in this project, a buck converter, some color sensors, a Hall sensor to control it. And we will go into the control loops now.
This is our speed control stuff. We use a Hall sensor, an interrupt, and a PWM to control the motor and monitor the speed. The Hall sensor generates pulses. Based on those pulses, we can use the interrupt to calculate the time difference between them, and using that time difference, we can calculate the speed that the RC car is going, and we have a little setup here that will determine if it's been too long since the last speed difference, and that determines whether or not we pass in the speed from our Hall sensor or just zero speed. We have a button that turns on and off our speed reference. And in the subsystem, we have our PID control. We pass in that speed reference and our feedback, calculate our PID stuff. That's all done in miles per hour. Miles per hour is then calculated to our millisecond time range for our motor control. That motor control is calculated into a duty cycle, and that duty cycle is passed through a PWM block controlling our motor and our speed.
This is our control loop for our color sensors that we have mounted on the bottom of the RC car. We have these custom-built I/O blocks that connect with the Arduino, the color sensors. We had to do this because it uses I2C. We had to collect the information from it. This is the CPP file that these blocks are referencing. And as you can see, it just gathers the raw data and the values of RGB, and then a C value, which stands for clear, which is in relation to the light level entering the sensor. When we initially set this up, we were using these clear values and looking at the difference between them to determine how we were going to be turning our RC car. However, we noticed that during the time of day and the sunlight heavily influenced how this worked, so we decided to switch it over to focus on the red value of both of these sensors. So the way this works is it compares both of these values using this sum block. Using this, it can say if the right sensor is detecting red, this will become a greater value, and it will make the car turn left. This is just a straight value, so we don't want to send any additional information if the car is going straight. We have our different values we use for a PID controller. And then the only thing that we had to do after that was put on a 90-degree plus offset. This is just for the servo motor that we used, because 90 degrees is meaning straight. And then that was just sent to our Arduino pin that controlled the servo, that controlled the steering. Now we will show videos of the car working before our PID tuning and after our PID tuning, as well as it going around the ring of the track. On this side.
All right, it's a little much. Dude. I'm glad you're recording this. That's perfect.